Okay, so good morning, everyone. Today we are going to talk about reinforcement learning. And the good news is that from this lecture, we're not going to talk about any calculation. Okay, so all the calculation for this course end up from this lecture. But for tutorials, I mean, for some exercises and the midterm, we still need. Okay, and after this lecture, I mean, I plan to finish this lecture in 1 hour, and then after that, I will talk about some exercises about calculation for previous lectures for you to understand what you need to do in the midterm exam. And yeah, so let's talk about the reinforcement learning first. And this is actually a very big concept. And it is quite difficult, I think. It's much more difficult than machine learning and deep learning from my point of view. And so it is not important for us to understand fully about reinforcement learning in a single lecture. So I'm just going to introduce briefly about the concept of reinforcement learning. Okay. So yeah, there are two contents in this class. First is the concept, and another is the model, the Markov decision process that we usually use to model the reinforcement learning task. Okay, then let's see what is reinforcement learning. So suppose that you have a puppy or a dog, right? So how you teach a dog to learn something? So the first thing, I mean, the first choice is that you search some YouTube video and then directly show the dog, like what's showed in the first picture. And of course, the dog is not able to learn anything. So it's like 一个敢教，一个敢学, right? And so the right way is that you give the dog a task, like you ask the dog to speak. And if the dog speak, you give him some reward, maybe some snacks. And then you repeat this procedure. And finally, the dog will able to learn like what you ask him to do. Although it might not understand the task, but he knows what to do in the correct way. So this is reinforcement learning, that you teach somebody, maybe a robot, to do something the right way with the reward. Okay, so this is called reinforcement learning. And yeah, here's some concept about reinforcement learning. So usually it is a software. There's an agent, like in the previous example, the dog is an agent. Okay, but in the machine learning task, usually it should be a software. And then it learned to make decisions by interacting with the environment. Okay, and then it can perform various actions. So it's like when you ask the dog to speak, it can keep silence or it can bark, right? And these are various actions that the dog can do. And then you evaluate the actions and then give reward to the dog or the agent. And finally, you identify the optimal actions for different states based on the reward. So this is the process of reinforcement learning. Yeah. Then let me give you a more concrete example. So let's see, let's take myself as an example, okay? So I have no sense of direction. 就我是个路痴, okay? And then every time I go back home from work, sometimes I will go to Welcome first to buy something, right? And then this Welcome is very close to my home. It's just like 200 meters away. And when I mean, for you, if you know if you have idea about the map, then you can see that the closest, the optimal route to my house, or to my home is the red route, right? But as I have no sense of direction, so sometimes I'll turn left after I cross the road. Actually, this is the real thing that usually I will turn left. I don't know why. So I've done this kind of stupid things for many times. And like the first time, I go across the road and then turn left and keep walking for a long way. And like maybe at this point, I realize that I'm taking a wrong way. So then I go back in this way and to my home by the right way. And then after several times, I do these stupid things. I realize these things when I reach here. Yeah, so like it's a gradual improvement. The second time I reach here and I realize that I'm going to a wrong way. And then the third time maybe here. And finally, after I just crossed the road, I realized that I need to go for a right way. I need to realize what the direction I need to go. So I will make a judgment here and then go to the right way to my house. So from my point of view, like reinforcement learning is just like a diligence can compensate for a lack of talent. It's like 勤能补拙. So if you repeat something for many times, in the end, you'll know how to do it in the right way. So let's see. We said that the agent in this reinforcement learning learns by interacting with the environment in different states. So in this example, the state here just means the position I'm in. Like I'm moving across the road, and then in different time points, I might be at different positions. So these positions represent for the states in this task. And then I can perform various actions. So I can either turn left, turn right, or go straight. These are all the actions that I can do, right? And then evaluate the reward and return from those actions. So if I'm going to the right way, then my home is closer to my current position. So this is kind of reward because I tend to return my home as soon as possible, right? So if I'm getting the right way, I will be closer to my home. But if I'm getting in the wrong way, then I will be far away from my home. Then this distance could be a reward or a penalty. And then according to all these things, I need to define the optimal action for every state. So it's like when I am here, when I was just outside welcome, the optimal action that I need to do is to go across the road. And then after I reach this point here, the next action might be turn right. So this is like my optimal actions for different states. Okay. So yeah, so reinforcement learning is based on the current state. And then in each state, the agent selects and carry out an action. Okay. And then the action will result in immediate reward. So let's go back to the first example, like when we are training a dog. Once the dog do some right actions, you should immediately give him some snacks or food to eat. Then he will know that he's doing the right way. If you give the food to him like after several hours, he already forgot about things. So that means the action should result an immediate reward. And then change the state. Okay. And then the objective of reinforcement learning is to devise an action plan for different states and then maximize the long-term returns. Yeah, so the objective, like say in the second example, is to build up a total plan, the whole road from my current position to my home, right? So in different states, I need to make different actions. And finally, I want to minimize the time to my home, or we say maximize the reward. Okay, and then we have deterministic and stochastic environments. Because usually it is not, the environment is not deterministic, that every time you do action, it will result the same, it will give you the same results. So deterministic means every time you do a single action, this action will give you a determined result. And then stochastic environment, it means things are always changing, right? So when you're doing action, the same action you do every day, it might result different outcomes. So this is called stochastic environment. Okay, so of course, deterministic environment is easier to handle. And it can be solved by traditional AI techniques like searching. And stochastic environment is much more complicated. Okay, so if you've seen this movie, like the Marvel, like the Avengers, when Doctor Strange predicting all the futures, there are like 14 million possible outcomes. And they only have one chance to win, right? So why they have so many outcomes, like 14 million? This is because the environment is stochastic. So we don't know like what will happen after this action, after our action. There will be several possible states that we will reach after a single action. Yeah. And then we also need to know about this exploration and exploitation. So I don't know if you go to some foreign restaurant, maybe in some foreign countries. And then like in China, usually we provide these figures of the dishes, right? But in quite a lot foreign countries and foreign restaurants, they only give you the name of the dishes. They don't provide you a single picture about a dish. And then there are various dishes that you can order. So some people might prefer to order some dishes he already eaten last time, because he might think he already eat it, so he know this is not bad. But some people might be, some people might prefer to explore some new dishes. But there's a risk when you order new dishes that you've never eaten, then the dish might be taste like shit, right? So this is kind of risk if you want to discover some new things. But if you never discover things, you might not able to have a chance to try the best dish in the restaurant. I mean, the one you like best. So this is kind of trade-off. And when you are trying new dishes, it's just like you are doing exploration. And when you are ordering the dishes you've already eaten last time, it is called a kind of exploitation, okay? So exploration means to explore new possible actions. And exploitation means to do the action based on the current learned knowledge. Okay. So yeah, this best action here means local best, local optimal. Okay. So you cannot, if you don't do exploration, then you might miss this global optimal. Yeah, so this is the trade-off of exploration and exploitation. Okay, so after that, let's compare that all the machine learning methods we've learned to now. So we've learned supervised machine learning, unsupervised machine learning, and reinforcement learning. And supervised machine learning is like we collect labeled samples, right? Labeled examples. And the only difference between supervised and unsupervised machine learning is like unsupervised machine learning collect unlabeled examples. But reinforcement learning is to giving decision about actions according to the interaction with the environment. Okay, and here are some learning mechanisms for different machine learning methods. So in supervised machine learning, how we evaluate the outcome is good or not. We compare the predicted result with example labels. And then in the unsupervised machine learning, we just find out the useful patterns in the data. However, in reinforcement learning, we are trying different actions. And then after different actions, we evaluate the reward, then to say what actions we should take, right? So it's like in the Avengers, the Doctor Strange evaluate all the possible solutions or actions that they can do. And then they find only one way that they can win this war. So they just do this action and then get the outcome of the reward that they win this war, right? So this is the mechanism of reinforcement learning. Okay, so and here are some applications about reinforcement learning. And the most famous one, I think, is the AlphaGo, right? So it's the game called Go, right? 围棋. And then it is initially trained with supervised learning, okay? But it then trained by self-playing, use some sampling method, Monte Carlo tree search. I'm not sure if you've learned this, but it doesn't matter. This is not content in our course. You just need to know this is kind of sampling method. And then it optimizes the strategy by reinforcement learning to know in different situation which way to go. Oh, yeah. And also we have an improved version of AlphaGo called AlphaZero, right? AlphaGo Zero. And then it is used pure reinforcement learning approach, right? So the difference between AlphaGo and AlphaGo Zero is that AlphaGo is initially trained with supervised learning first, with some data from some human experts. And AlphaGo Zero, it's purely depends on reinforcement learning. And it trained faster and performing better than AlphaGo. Yeah. And also we have some success in the mobile games, right? I think most of you should know this, right? Like if you've played Leagues of Legends, LOL, or something like Honor of Kings, 王者荣耀, then you know that there are some that you can play with bots, right? You can play with the bots in the game. And maybe several years ago, you feel that the bots are very stupid. They can never beat you. They can never defeat you. But recently, they've released some intelligent bots, right? They improve the level of the bots, and then the game become much more challenging. Okay. So this is some applications about reinforcement learning. And reinforcement learning are usually modeled as a Markov decision process. It's also called MDP. Yeah. So we usually use this method to model a reinforcement learning task. And then the MDP is defined by 5 components. Actually, we've already mentioned all of them before. So firstly is the time, T. So this is the time points of your task to give you a time scale. Okay. And then S is all the possible states. Or we see it is a state space. So yeah, just to give you a better understanding. So like all the possible states here, like in this map, when we're doing planning about the route, then all the possible states are all the locations that we can reach. Okay, so this is means like the states in the environment. And then A is the set of all possible actions. Again, in the previous example, like when I'm going back to my home, all the possible actions is like turn left, turn right, or go ahead or turn back, something like this. These are all the possible actions in all the possible states. Okay, and this is referred as A. And then with this S and A, we will have a reward. So in each state, after we take an action, we will have a reward. So it's just like when you're feeding the dog for his well performance. So this is the reward. Okay. And we also have a transition probability. Yeah, this is a difference. Lead to state to the next state. Because we've talked before, we have deterministic environment and the stochastic environments. So in the stochastic environments, after we take some certain actions, we don't know what will the result be, but we have several, possible outcomes that we know. So then it will lead to different states with different possibilities. Yeah. So this is like how we do this MDP process, okay? So in the previous figure that we already showed you in the second slide, I think, after the agent do a certain action in a certain state, okay? Like the dog. Let's see, we have a dog. And then we ask it to speak, it barks. Then we will give him some reward, right? After he barks, we'll give him some reward. And then this reward is like a feedback to the dog, the agent. And then after he did this action, he will go to a new state. For example, eating the food, that will be a new state. Okay. And then if we explain it in a more mathematical way, so we have a state ST here. And then we do some actions. The action will be some input to the current state. And with this action, we will reach a new state. And also, after we've done this action, we will also get some results. Sorry, reward. This is reward. This is the next state. And this is the action. Okay, and this is the current state. So it's like when we are walking on the road. So if we just turn right, then we will turn right and then take several steps, we will go to another location. That means we reach a new state from our current location. And then after we reach the next location, we measure how long we are away from our home. I'm away from my home, then there's a kind of reward. Okay, and the action maybe kind of turn left or turn right. Okay, this is the transition in the MDP, Markov decision process. Okay, and then we have transition probabilities that we say that sometimes the environment is stochastic. So when you have action at the current state, we have A, right? This is AT. Action at the current state of ST. And because it's stochastic, it might have several outcomes. We might have the possibility to reach to 3 different new states, like S1, S2, S3. Let's see, but the total possibility will be 1, right? 100%. 100% we will go to the next state. Yeah, but actually there is one thing that you can go back to the current state, okay? Let's say we have 4 different possibilities. We have 4 different possibilities. One is that we take this action AT, that we will reach S1. We have 10% possibility to reach S1, and we have 20% possibility that we will reach S2. And maybe we have another 50% that we will reach S3 after we take this action. Also, we might have some Yeah, the remaining is 10%. We have another 10% possibility that we will still keep in the current state. So this is the transition probability, that every time you take a certain action in a certain state, it will have this different possibility to reach to different states for the next time point. Okay, so this transition probability. And the summation of the probability should be 1. Okay, probability 1. And then in the deterministic system, we only have, because it is deterministic, so the outcome is determined. Okay, and the outcome is determined. So the difference is like this. We have ST here. Then it will be 100% that we will go to this state. Okay, so this means deterministic. This is deterministic. And this is called stochastic. Stochastic. How to spell it? Stochastic. It's stochastic. So yeah, something like this, ST to S1, or you can also do like ST to S2, doesn't matter. But the possibility will be always 100%. Okay, so this means it is a deterministic system. Yeah, so we have some important property for Markov decision process. The most important thing is that the next state depends only on the current state. Okay, this is the most important property of Markov decision process. So it's like when you're applying for maybe a master degree, they will only ask you about your GPA during your undergraduate, right? They will not ask you about your performance in your high school. So this is kind of, it depends only the current state, but not any previous states. Obviously, let's say we have a process like this. Okay. We have ST plus 1. And then we have several different states when we are doing actions in ST. And then we also have some different actions that we can do in ST plus 1 that we arrive. And ST, maybe ST3, S4, doesn't matter. Okay, S1, S2. So when we are calculating the possibility of reaching from ST plus 1 to S3, this possibility is only depends on your current state, ST plus 1. You don't need to think about the previous process, that how you reach this point. So this is called memoryless, okay? It doesn't remember the history. It only holds all the information in the current state. And this is the most important property of Markov decision process. Okay, and then here are some formulas. Actually, not very important. So yeah, just like we have reward. We've already talked it for many times. And this reward is generated by the environment according to the current state and the current action you take in this state. And then with this reward, we will have a return, something called a return. So this is the cumulative reward. Okay, so this is like the cumulative reward. You just sum up all the rewards you have. And then there's a discount factor in Markov decision process. Because sometimes the process is very long, and then you need to keep adding reward to this return. And this return will be a very big value if the process is very long, like in the long-term reward, okay? That's why we need to put the discount factor in this reward. Avoid the return to be infinite. Okay, yeah. This is about the reward, return, and discount factor in Markov decision process. And the target of Markov decision process is to find the optimal policy. Okay, and a policy means the function map a state to an action. So it's like an action plan. Like, let's go back to the first slide. Like here, if I'm going to find the shortest way to my home, it means the optimal way, right? The optimal policy. And like the red route here should be the optimal policy. And this is kind of a set of actions that I did. For example, I crossed the road. The first action is that I cross the road and then I turn right to here. And then I turn left in this corner and then reach this home. And all the actions I've done is called this set of policy. And the target of this Markov decision process or this reinforcement learning process is that to find the optimal route or the optimal policy. In this case, it's the route. Okay, so this is how you understand this policy. Yeah, and the policy can either be deterministic or stochastic before I talk about it. Okay. And for the formulation of the MDP, it's just like we want to find the pair of S and the pair of state and actions about what action we should do in each state to form up this policy. Okay. And let's see here as an example. This one, okay. And let's say these arrows here represent for the direction of the wind on the sea. Okay, and then you are driving a boat on the sea. And then you can see if you are here, if your current state is here, of course, and then you want to reach the state here. So you have two choices to reach the state here. One is that you go this way. Okay. Another is you go this way. And then if you calculate the amount of the steps that you need to go, they are the same. And the only difference here is that the direction of the wind, right? So you tend to go in the same direction as the way that you can go faster. So that if you are in this current location, then your optimal policy might be the root here, right? However, so let's see if your current location is here, here, maybe here, then it will be more complicated. Because if you go in this way, the first way is like you go this, okay? So you're always in the same direction as the wind, that you can go faster, but the distance is longer, right? And then if you go in this way, you have shorter distance, but sometimes you are facing with the opposite direction of the wind, that you might have a slower speed. So this is like what we need to solve in this MDP process. And so this is a deterministic, let me see, this deterministic example, okay? And like in this example, how we make it to be stochastic, okay? So it's very easy. That we put the direction of the wind related to the time, okay? So maybe we have different time point, right? And then the wind direction at the beginning is like this. And then at the third time point, the wind direction changes as the weather changes. So it usually happens, right? Then you introduce some stochastic factors to this example. And then this policy, when you decide this policy, it will be much more complicated than the deterministic example, right? And this is what we need to solve in this MDP process. But we are not going to talk about the details, okay? Because we need to take several lectures to talk about these things. And I think like we need to have a independent course about reinforcement learning if we really want you to understand this concept, okay? Okay, so now it's the end of this class. I mean, yeah, of this lecture, I mean, of this content of this lecture 6, I think. And then we will have a break. And after the break, I'm going to talk about some questions that you might meet in your midterm exam. And if you haven't taken your attendance, then you can take attendance here. Mm, mm. Mm. Okay, so let's start talking about the tutorial. I mean, some questions. So yeah, for the first two questions, it's just like some concept. I'm not going to talk about it here. I'm just going to talk about the calculations that you might meet in the midterm exam, okay? So the first thing is about the KNN, okay? KNN. And it is 100% it's going to be exempt, okay? So we will have 20% single choice questions, 60% calculations, and then 20% about the lab. Okay, and then this 60% about of calculations will include the linear regression, the KNN, and the K-means. Okay, so now I'm going to talk about the KNN here. So here we want to find, so usually we use KNN to do classification, right? And now here we have a table. We have a table of data here. And we have three features here. We have three features. We have three features here: the speed, the efficiency, and the cost. Okay. And then this is the label. This row is the label. Now we have a new data. We have new data here. We have new data here. This is the new data we have. And then according to this new data, we want to find which class it belongs to. And this is the problem we want to solve, okay? And then we can change the parameters of K to decide what the class should be. So in different number of K values, the result might be different. So we will calculate when K equal to 1, 3, or 5. Okay, then we start our calculation here. To black. Okay. Okay, so what's the data point we have? The data point here we have is 0.6. 0.6. Okay, I'll sit here. 0.6. 0.9. Okay. 0.6, 0.9, and 0.3. Okay, this is the data point we have. And then we need to calculate the distance between these data points. This is a new data point, new data. So all other data points. And all other data points is here. It's here. We have all data points here. In total, we have 5 data points. So we need to calculate the distance of this new data point to all other 5 data points. Let's calculate it one by one, okay? So the first data point is A. And the distance is calculated as 0.6 is this first data point, the data in this first data point, the new data point, okay? 0.6 minus 0.9. So it's the distance between these max speed, okay? This is 0.9 here. Why I cannot write here? Okay, doesn't matter. Okay. And then we squared it, okay? Then we calculate the next one. It should be the 0.9 here. 0.9 minus the 0.5, 0.8, okay? Here, the second, power efficiency. Now we are calculating the power efficiency. Is 0.8. We square it. And then we calculate the cost. It's a 0.3. Here is the cost. Minus 0.1 in the first row of A, okay, the cost. 0.1. Okay. This is the distance. Actually, you can use a square root here, but not necessary, okay? And the value will be, this is just like the relative distance. Okay, and then if you calculate the distance, it will be 0.14. And then we calculate in the same way for B. It's still 0.6 minus 0.5. And the efficiency is 0.9 minus 0.1. And the cost is 0.3 minus 0.8. Okay, and then the result is should be 0.9. Okay, you can calculate by your calculator. So when you are doing your midterm exam, please bring your calculator. Okay, don't forget about it. And then in the same way, we calculate for C, D, and E. Okay, and then we find that the distance between this new data point and C, let's see, this new data point is maybe Z, new data point Z. Okay, then the distance between C and Z is 0.66, and for D is 0.82, and for E is 0.09. Okay. So these are all the distance we calculated. We calculated 5 distance. And then we need to decide the class of the new data Z according to the value of key. So if we choose key equal to 1, let's see if each key equal to 1. K equal to 1. That means we select the minimal distance sample, which is E, right? Minimal distance to E. Okay. And then as E, we can say E here. You can say E here, right? And the class of E is good. So we know E is good. Okay. So if E is good, then when K is equal to 1, X should also be good. X. Right, the class of, sorry, X, not X. It should be Z. Okay. So this is when X, a key equal to 1. And then when key equal to 2, then we need to, 3. Then we need to find the 3 minimal distance, 3 mean distance. Okay, so what's the 3 mean distance? It should be E, and A is 0.14, right? And then C. Okay. Then we know that E is equal to good. A is good. C is bad. And then according to the majority vote, we know that Z should be good, right? So with all these 3 results, we have 2 is good, 1 is bad. So according to the majority vote, the Z should be good, 少数服从多数. Okay. Then in the same way, we calculate 5, K equal to 5, which means we find out the 5 minimal distances. And in total, we only have 5 data here, A, B, C, D, E, right? So this should be A, B, C, D, E together. And then we find that there are 2 bad, 3 bad, 3 bad, and 2 good. So when K is equal to 5, then Z should be bad. Okay? So in total, we have the result here. When K is equal to 1, Z is good. When K is equal to 3, Z is good. When K equal to 5, Z is bad. So this is the result of the K and N when the key varies from 1, 3, and 5. Okay, and this is about this question. Any problems here? Okay, if no, then let's go to the other tutorial, which should be tutorial 6, tutorial 7. And tutorial 7 is about k-means. Okay, and this is also going to be examined. And here we have 7 data points. And then we want to put it into 2 clusters. So it means K equal to 2. Okay, 2 clusters. 2 clusters. And it gives you the initial centroids 0 and 1 and 2 and 4. So we should first compute the distance and then update the centroid. So here it asks you to run the algorithm for 2 iterations. Doesn't matter, okay? I will only ask you to run it for 1 iteration. 1 iteration, okay? Okay, then let's try to do this one. So we have the centroid, initial centroid, initial centroid. Okay, we have 2 initial centroids, C1, 0, 1, and C2, 2, 4. Then we need to calculate the Euclidean distance between all data points and each centroid. And we have 7 data points, right? 1, 2, 3, 4. We have 7 data points. Data. Okay. Data we have is 0, 0, 1, 3, 2, 2, 2, 3, 3, 3, 5, 4, and 3, 4, 3. These are all the data points we have. Then we need to calculate the Euclidean distance. So we first calculate the Euclidean distance from C1 to all other data points. We calculate Euclidean distance. Euclidean distance to centroids. Sorry. To centroid. Okay. So firstly, we calculate the Euclidean distance to C1. I'm not going to write all the things here, okay? I'm just going to give you the formula of Euclidean distance. So it's like x x1 minus x2 squared plus y1 minus y2 squared square root. Okay, this is the Euclidean distance. Suppose you have two data points, x1, y1, and x2, y2. Okay, so this is the Euclidean distance. Then we calculate for what C1 and C2. And in this, according to this formula, the Euclidean distance for C1 to all these data points should be 1 and 2.24. Then the same, 2.24. And then 2.83. And then 3.61. And then 5.4.47. Okay. So these are all the Euclidean distance from C1 to other data points. Also, we need to calculate the Euclidean distance from C1 or C2 to other data points. And it will be 4.47, 1.41, okay, 2, then 1, then 1.41, and then 3, and then 2.24. Okay. Then we need to group the data to each centroid. Okay. So we just compare the data points, the distance for this the distance from C1 to these data points and to C2. Okay. So we compare these data pairs. Okay, so in total we have 1, 2, 3, 4, 5, 7 data pairs, right? So this represents for the distance from C2 to all the data points and C1 to all the data points and C2 to all the data points. So now we want to know for each data point, this should belongs to C1 or C2. So if it is closer to C1, then it belongs to C1. If it is closer to C2, then it belongs to C2, okay? Then we can see only this C1 here is smaller than C2. And all other data points, C1 is bigger than C2, right? So then we know, let me see like this. Data belongs to belong to C1. And we have data belong to C2. Okay. So data belong to C1 is the first data point. It's the first data point here. Okay. And the data belongs to C2. It's all other data points. 1, 3, 2, 2. 2, 3. 3, 3. 5, 4. And 4, 3. Okay. Then we need to update. We need to update the centroid. So how we update the centroid? We use the center of the data points in a certain group, right? Oh, sorry, I forgot to write something here. This is C1, okay? Okay, C1. Then we calculate the centroid of C1 first. New update. Updated C1. Okay, because C1 only have one data point in this group. So the center will be the data itself, this data point itself. So this is center. And then we need to calculate the updated C2. So C2, we have other 6 data points inside. So the center will be the average of them, okay? So it's like the average of X and average of Y. So average of X is equal to 1 plus 2 plus 2 plus 3 plus 5 plus 4. And in total, we have 6 data points. And then the average of Y should be 3 plus 2 plus 3 plus 3 plus 4 plus 3. divided by 6 again, okay? And then it should be equal to 2.83 and 3. Okay, then this is the updated centroid, okay? And then this is for the first iteration. And we will only calculate the first iteration. We will not calculate the second iteration. So this is all the things you need to know for this calculation. Any questions? So in the end, we have the updated centroid C1 and C2. Okay. Then let's go to tutorial 5. Tutorial 5 is about logistic regression. Logistic regression. Actually, it's quite easy. Okay. So here it gives you a model. Recording, right? Here it gives you a model with 3 parameters. And features. Here, 3 features. And the target and training data. Also the sigmoid function and the loss function of cross entropy. So you want to, it asks you to write down the complete cost function. Okay, so this is not going to be examined. Okay, I'm just quickly going through this. Okay, so we know that the loss function of logistic regression with cross entropy should be like this. Okay, let's first try to write down the function. The loss function G, and it equal to this one. The summation from I equal to 1 to n. Okay, and then we have y I log log hx h theta x I plus 1 minus yi. If you forget about the formulation, you can look at the lecture notes in lecture 4. 1 minus h theta xi. Okay. So this is the loss function for the sigmoid, sorry, for the logistic regression. And then we just need to put all the information in this question inside this formula. So firstly, we know that h theta, okay, we know that h theta xi is equal to the sigmoid function. Okay, so it's like with the sigmoid function. So this is also the formula in the lecture, okay? And then we just need to put the sigmoid function inside to replace the h theta x inside, okay? And I'm not going through details here. Okay, put this h theta x. What the? To this and here. Okay, just put this formula inside. And also, you should know that here, what is this part? The theta xi. Okay, the theta xi, theta transpose. This is because the matrix format, okay? Theta transpose xi is equal to theta 0 because it has give you the features and the model and features here, right? The model and the features, it is given you here. So you know this multiplication of these model and features is equal to this way. Theta 0, x 0, plus theta 1, x1, plus theta 2, x2. Yeah, and then you just put everything together. You got the final formulation of the loss function. Okay, and this is how you calculate the loss function for logistic regression. But this is not going to be exam, okay? It's just a example. Okay, yeah. So now it's the end of this class. We still have some time left, but it's okay, yeah. Okay, so thank you very much and see you next week. And the final, the mini project will be released after the midterm exam, okay? After the midterm exam, we are going to talk about the mini project.